Alright, in this video we're going to do some problems from your assignment on page 374 for 8.8. I thought I'd start with 23 because it's the first time when you have x's on both sides of the equation up in the exponent. Um, Now I'm just following the directions when it says solve by using natural logs. Since there's no e in the problem, of course you could have used common logs, but again the directions say use natural logs. So after you took the natural log of both sides, bring the exponents out in front, then we have this. So now we have some options. Some people in class were dividing both sides by ln2, getting a ugly decimal number, and then working with it. And that's fine. I just thought I'd show you another method that does not involve working with any decimals, and then it's calculator work in the end. So our goal right now, when you look at natural log of 2, it's just a number. Our goal is going to be to get both of the x terms on one side of the equation. So to do that, we need to do this distribution because ln of 2 is just a number, ln of 5 is just a number, so we're going to distribute this on both sides. All right, now that I've done the distribution, we want to get this term and this term on the same side of the equal sign, and the log values that are just numbers, we're going to get them together on the other side of the equal sign. So I'm going to subtract an x ln 5 from both sides and add a 6 ln 2 to both sides. All right, now that I have both terms with x's on one side of the equation and the numbers on the other, to isolate this x, we're going to do the GCF on this side because both of these terms have an x in them. And so pulling out an x out of both, now I have this equation, which becomes a lot of calculator work. Okay, this is no different from back in the day when you had a number times x equals another number, and you're just going to divide both sides by this number that's next to your x. So this just becomes a ton of calculator entry, but then we don't have to deal with any ugly decimal numbers in our work. So when you enter this on your calc, please use parentheses or brackets for the numerator, the entire numerator divided by the entire denominator. And if you enter that in, you should end up with negative 9.808. All right, let's look at problem 30. So after you read through it, perhaps the 30 months were confusing, or kind of an unusual interest rate of 3.8, whatever. If you saw the words in there compounded continuously, we know we used the formula with the E in it. So plugging in the 12,000, the interest rate, and the fact that 30 months is 2.5 years, that's where the 2.5 came from. So if we multiply this out on our calculators, we end up with $13,195.91. All right, reading through problem 31, I hope it's very clear to you that the 8,000 is the starting amount, the ending amount is 11,500, and they want to know how long it had been invested, compounded continuously at the 10.25%. So plugging in the numbers where they belong, and again, before you take the log, the natural log of both sides, you will be dividing out the 8,000. So divide it out, take the natural log of both sides, bring the exponent out in front, and then that turns out to be 3.5 years is how long it was invested. All right, what's different about 32? They did not tell us the interest rate, and that is what we need to find this time. So again, putting in the values where they belong, we started with just over 500,000, ended with over 800,000 after the 4 years. So putting those numbers in, and once again, divide both sides by the 55,000. Try that again. 550,000. Remember, you always have to isolate the base before you take the natural log of both sides. So divide this out, take the natural log of both sides, pull the 4 out in front, and then if you solve this, you should end up with an interest rate of 10.2%.